everyone, welcome to day 8 of distance learning for my block 3 and 4 class. If you haven't done so already, please pause this video right now to answer the attendance question on Google Classroom on this stream. The first thing that you do each day should be answering the attendance question so that you can be counted as present for that day. Otherwise, you will be marked as absent. The second thing that you should have done was read the feedback on the day 6-7 assignment that you should have handed in by midnight last night. And you should also check the answer key that was posted on the stream on Google Classroom. Remember, answer keys are not available to you. They're not visible to you unless you have submitted the assignment. Okay, so if you have done those two things, you also need a printout of this packet or at least some line paper so that you can copy down everything that I'm doing. We're starting a new lesson today. It's going to be related to the solving systems of equations that we've been doing for a few days now, but we're just going to be looking at word problems. And the word problems is what's going to pretty much be the last part of this chapter, chapter 4. So just follow along with me, and if you have any questions, you can post in the comments below, or you can post on Google Classroom either on the stream, on the day 8 post, or on the assignment post, or you can email me if you can't reach me there. All right, let's get started. So I'm going to start reading from the top. 4.2.2, how can I organize the possibilities? Part 1. Businesses and industries often use equations and inequalities to model their services and production. Creating a system of equations and inequalities allows them to mathematically optimize their operation and maximize profits. Today, you will investigate this technique. So for the majority of this packet, we're going to be looking at this toy factory called Autotoyum. They build toy cars and trucks. To make each car, he needs 4 wheels, 2 seats, and 1 gas tank. To make each truck, he needs 6 wheels, 1 seat, and 3 gas tanks. His storeroom only has 36 wheels, 14 seats, and 15 gas tanks total. He is trying to decide how many cars and trucks to build so he can make the largest possible amount of money when he sells them. Help Otto figure out what his options are. So letter A says, what are all of the choices he can make about how many cars and how many trucks he will build? And we're going to make a list of possible combinations. You were warned there would be a lot. I made my X coordinate my number of cars and my Y coordinate my number of trucks. And thank goodness I made all the coordinates for you, because this does take a long time. If you did do this in class, if you were assigned to do it, it would have taken at least like 20-25 minutes because of all the math that you have to do in your head or on the side. But basically, he can choose not to build any at all. Obviously not good for like profit-wise, but he doesn't have to. He can choose not to build any cars and 1 truck, and he can choose to build 0 cars up to 5 trucks, because it looks like once he hits 5 trucks, he gets the 15 gas tanks that he has, and he can't go any further. And then I kind of just filled in everything in between, and then it looks like the most cars that he can make is 7, because right here 7 times 2 is 14, and that'll fill up all the seats that he has, and then he can't go any further. And then to get everything in between, I kind of just did the math, like he can make 1 and 1 because he'll have enough of the wheels, the seats, and the gas per car and truck. So again, this does take a while, but here it's all for you. And this is very cumbersome, so we're going to end up using a system of equations to solve this for us instead, because like I said, it probably would have taken about 20 or 25 minutes. And letter B, you're just asked to plot all the coordinates, so I just literally took all of these and plotted them down here. Remember, in my class, whenever you make a graph, you should always label the axes. So here I have number of cars, number of trucks, and then it makes a shape with all the possible combinations of cars and trucks that he can make with the amount of wheels, seats, and gas tanks that he has in his storeroom. So right now we're just going to flip over and we're going to answer 2 questions before we actually use a system of inequalities to solve these. Some of you are getting confused on the classwork so far between systems of equations, and you are solving for the intersection. We're doing systems of inequalities now, so you need to be shading either up or down, above, below, left, or right, and then the overlap of shading is where all the solutions are. So if you are finding intersection points, you are not following the directions. Okay, let's answer some questions about Otto and the stuff on the first page. He wants to make as much profit as possible because now that he knows his possibilities, we can talk about money. Use your list from problem 4-79 to find which combination of cars and trucks will make the most profit based on the information below. So letter A says, which of Otto's options gives him the greatest profit if he makes $1 per car and $1 per truck And how do you know? So you can kind of just go to the front page where we have all his possibilities. If he makes $1 per car, $1 per truck, you basically just have to add the coordinates then. So which one will add to the most profit? Here I have $6. Here I have 7. Here's 8. Is that the most? That's 7. Will anything get me to 9? I don't see anything. That just gives me $7. So it looks like 6 cars and 2 trucks will get him $8, which is the most profit if you were to make $1 per. All right. If profit is 1x plus 1y, $1 per car and $1 per truck, then the most profit he can make is from 6 cars and 2 trucks, and that is a profit of $8. Okay, let's go on to letter B. The market has changed and he wants to do $2 for each truck and $1 per car. What is his best choice? So now we go back to the front. So if he were to make $2 per truck instead of just the $1, what would give him the most profit? So basically we're doubling the Y value and adding it with the X value. And it looks to be that, because then it'll be 3 plus 8, which is $11, right? I don't think anything is more than $11. That'll be 9. So I think it's 3 cars and 4 trucks. And that'll get him a profit. Ooh, I didn't write an equation, but if he makes still $1 per car and now $2 per truck, that'll get me now 3 plus 4 times 2, which is 3 plus 8, which is a profit of $11. So those are just the 2 extra questions from the first page. So now we're actually gonna solve this in a much easier way. So look down at 481. To convince Otto that your recommendation was the good one, you probably had to show many calculations, and believe me, you would have had to if you did this on your own. Now you will take another look at Otto's business using algebra and graphing tools. So our first step is we're going to write 3 inequalities to represent the relationship between the number of cars, we're going to make that X, and the number of trucks, Y, and the number of wheels, seats, gas tanks. So you guessed it, we're going to have 3 inequalities for this as opposed to just the 2 that I've been giving you this whole time. So let's just make an inequality. And when you guys are doing these, you're thinking like your system of equations, except instead of an equal sign, you're going to decide if it's going to be less than or equal to, greater than or greater than or equal to. So there's just one extra step when it comes to the inequality symbol that you're using. So for the wheels, if each car needs 4 wheels, that's 4x. And each truck needs 6 wheels, that's 6y. And we're going to be adding them together because together will take up all the wheels that he has in his storeroom. The max that he can go is 36. So they can use less than 36 wheels. They can use all 36 wheels, so that'll be equal to and 36. So the amount of wheels that they use has to be less than or equal to 36. And it's going to be a similar mentality for the seats and the gas tanks. So 2 seats per car is 2x. 1 seat per truck is 1y. I'm just going to write y. And that has to be less than or equal to 14 because they can use all 14 seats and they can use less than 14 seats, but he doesn't have more that he can use. And lastly, for the gas tanks, it's 1 per car. That's x plus 3 per truck, and it has to be less than or equal to 15. He can use all 15 gas tanks or less than 15, but he can't use any more because he physically does not have any. All right, so now that we have our 3 inequalities, this is the system, and we're going to combine all of them and graph them on the next page. So one key thing that I want you to take away from this video is, yes, you're going to be solving your systems of inequalities the same way as before, but now because you might have bigger numbers to graph that are off the axes, meaning that you might have to scale, like count by 2s or count by 3s, it's much easier to graph with your x and y intercepts. And I'm going to remind you how to do that because basically you just have to solve for the x-intercept, solve for the y-intercept, put those 2 points on your graph and literally just connect them with a line. You don't have to get y alone and put a dot on your y-intercept and then go down and over for your slope at all. It's just as easy as graphing 2 points and connecting them with a line. So I'm going to flip over. And here I already have my axes labeled, so number of cars, number of trucks, just like the one that we had on the first page. I have my 3 inequalities rewritten again to show his constraints. And I'm going to graph these using the x and the y-intercepts. So to remind you, to find an x-intercept, you just plug in 0 for y. And to find a y-intercept, you just plug in 0 for x, because an x-intercept, the coordinate is always some number, comma 0. Your y-coordinate is always 0. And for your y-intercepts, it's always 0, comma some number, so x is always 0. So basically, x-intercept, plug in 0 for y. For a y-intercept, plug in 0 for x. So basically, that's just as easy as kind of covering it. So if I just plug in 0 for y, this goes away. So that means my x-intercept, and just divide both sides by 4 to solve for x, your x-intercept is just 9. That's 9, 0. And here, if I just plug in 0 for x, and I divide both sides by 6 to solve for y, my y-intercept is just 6. So be careful with which is which, okay? 0, comma some number is always a y-intercept. Some number, comma 0 is always your x-intercept. I'm going to do the rest of my 4 before I actually graph these. So here, if I plug in 0 for y, divide both sides by 2 to get x alone, my x-intercept is 7. Here, if I plug in 0 for x, which is basically just covering this up, my y-intercept is 14. So I wouldn't have known that I had to go all the way up to 14 had I made my graph already. So see what I mean by you might have to scale. And then lastly, the x-intercept here is 15. And here the y-intercept, to get y alone, I just divide both sides by 3, so that'd be 5. And now I'm going to graph all 6 of these intercepts, and then I'm going to connect them with a line. They're all going to be solid lines because it's less than or equal to for all of them. I'm actually going to use a pen this time. So for this, let's see. If the largest y value that I have to graph is 14, I don't think there's enough here, so I'm going to count by 2s. Let's use my pencil. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So I counted by 2s for my trucks. The largest x value that I'll have to graph is 15, right? So I'm probably going to have to count by 2s for those as well. 2, 4, 6, 8, 10, 12, yeah. And that goes up to 24, it looks like. Okay, now let's graph. So 9, 0 is my x-intercept for the first one. That's right here. 0, 6 is my y-intercept for that same line, and that's right here. And then I'm basically just going to connect these 2 dots with the line, and then you've graphed the first inequality. It's as easy as that. I have to put my phone down to connect with a ruler, so I'll be right back. Okay, now let's just graph the second inequality. I have a y-intercept of 7, 0. Sorry, an x-intercept of 7, 0, and a y-intercept of 0, 14. And again, I'm going to connect my green points for that inequality by putting my phone down and using a ruler. And for the last one, I have a purple pen, and I have 15, 0 as a y-intercept. Sorry, I keep mixing it up. 15, 0 is the x-intercept. And y-intercept is 0, 5. Just directly in between 4 and 6. I'm going to connect those 2 purple points with a line to make the line for my last inequality. So now here are my 3 lines, and remember I made them solid because it was less than or equal to as opposed to dashed. Dash would have just been a less than or a greater than sign. And now my last step to show my solutions is I just have to shade, and since these were all less than signs, that means you're shading below for all of them. So I can see that my overlap ahead of time is going to be below all the lines, which is just going to be this weird figure right here. So I'm just going to shade that in with pencil. everywhere below. Below the purple, below the blue, and below the green. These are my solutions. With the amount of seats, gas tanks, and wheels that he has, he can only make these coordinates for cars and trucks. Otherwise, he will run out of stuff and not have enough at all. So if you remember, this is the exact same shape from the front page with all the coordinates that we have here. So it's basically, we got the same thing, but it was a lot less steps. This took me a lot less than 25 or 30 minutes that it would have taken you guys to do the front page if I had you do it on your own. So now that we're done with that, and remember, if you use all different colors, please point an arrow to the shape so that I know that you know where the solutions are, because a lot of you were hitting your work last week. I couldn't tell where your solution regions are because it was a different color for each problem and you didn't have an arrow. So if you use all three colors, you need to like point an arrow or at least highlight it for me so that I know that you know where it is. Last question here is, why is it okay to assume that x is greater than or equal to 0 and y is greater than or equal to 0? Well, you can't make negative cars or negative trucks. That's why. So we don't even need the rest of the coordinate plane. We don't need the other three quadrants because we're only graphing positive cars and positive trucks. So a negative number of cars or trucks is impossible. So I'm going to pause right here because basically when you have a word problem, you just have to get your inequalities, whether they're 2 or 3 or more, based off of the information that you're given. Make sure you designate your variables. The x was the cars, the y was the trucks. Graph using the intercept. So I should see some side work. If you can do it in your head, that's great. You can do it in your head. You need to graph your lines, make them solid or dashed, shade below, above, wherever, highlight your solution region, which is the overlap, and make sure you just have labeled axes. At this point, I would probably ask you to like test a point or give at least one combination. So you can do like 2, 2, 2, 4, as long as it's in the shaded area, 4, 2, 7, 0, any possible combination will be in here in the shaded area, any coordinate. Anything outside of here won't work. He won't have enough material for. And basically you would test it by plugging your coordinate of choice into all three of these, and it should work for all three. And if you have the correct solution region, it should definitely work. So if it doesn't work when you plug it in, you know you've made a mistake. So basically the rest of the paper is just profit stuff, just like we did on the back of the first page. So these are just extra questions. Please follow along. So what are the vertices of the pentagon that outlines your region? So pentagon is a five-sided shape. We have 1, 2, 3, 4, 5. Yeah, we did get a pentagon. What are the vertices? So those are just the coordinates of the corners. So it looks like one corner is 0, 0. Another corner is 0, 5. Another corner is, it looks like it's halfway here, so 3, 4. And these corners are going to be important because it's something that we're going to talk about later on. And this one looks to be 6, 2, right here where the green and the blue intersect. And my last corner is right here, which is 7, 0. Letter D, are there any points in the solution region that represent choices that seem more likely to give Otto the maximum profit? Where are they and why do you think they show the best choices? So basically, the shaded region is the only combination he can make, so we should only be looking there. So that would be part of the answer. Which would be more likely to give him profit? Well, I would say maybe these points, because at these points, probably not 0, 0 by common sense, because if he makes nothing, he's not making any profit. But here it's like if he uses up and if he makes all 5 trucks, then he probably used up all his resources. Here for 6, 2, wow, he made a lot of cars, and then whatever he had left over, he made trucks. And then you also have 7, 0 means he made all 7 of those cars and he has nothing left over to make any trucks. So these corners kind of represent the max amount that he can make still being in the shaded region and him using up all of his material so that he can make the maximum profit. So be in your shaded region in the corners, with obviously 0, 0 not being the best choice. So in the shaded area, the vertices or the corners might make him the most profit. Because that's probably where he used up all of his material, and basically the more material he uses, the more money he will make, because that means he made the most cars or trucks, if that makes sense. We only have a few questions left that have to do with profit. So write an equation to represent his total profit if he makes $1 per car and $2 per truck. I've really already done this already on the back of the first page, but $1 per car is 1x and $2 per truck would be 2y. What if Otto ended up with a profit of only $8? So 8 equals x plus 2y. Show how to use the graph of the profit equation when P equals 8 to figure out how many cars and trucks he made. Well, you could literally just graph this and it'll show you the combinations that he can make to get $8. So I'm just going to graph with the intercepts. So my x-intercept is 8. And I'm just going to use pencil for that then. Actually, pen. So I can differentiate. The y-intercept, you have to divide both sides by 2 to get y alone, so that's 4. So I'm just graphing that line to show where it lines up in my shaded region, and I'm going to connect it with my ruler, so I have to put my phone down again. So now if you look here, it lands in your shaded region except for this part right here. So we know all the coordinates on this line will get him a profit of $8. So if he makes 0 cars and 2 trucks, that'll get him $8. If he makes 2 cars and 3 trucks, because that's another coordinate on the line, 4 cars and 2 trucks, and 6 cars and 1 truck will all get him $8. So everywhere that's in the shaded region that is on that line will get him $8. And now I'm just going to flip over and basically similar question. So which points do you need to test in the profit equation to get the maximum profit? It is necessary to try all the points. Why or why not? So basically tied to what I said before, we're just going to try those corner points again. So the vertices. Check the vertices. So the previous problem had us check where would get us $8, but is that the most that he can make? Well, we just have to plug into the profit equation. We're going to just plug in our vertices, our corners. So we said that they were 0, 0. What else? 0, 5. 3, 4. 6, 2. 7, 0. So if he still had, we still have our $1 per car and $2 per truck, which would make him the most profit, which of these? And it's not going to be the $8 that he could, and because we already figured this problem out, it's going to be $11. So it's that 3, 4, this one right here. So if we plug in 3 plus 2 times 4, that'll make him $11, which is the most profit that he can get if he chooses to do $1 per car and $2 per truck. You can try plugging these in as well, but again, we've already solved this problem on this page right here. We got 3, 4. G, what if Otto got greedy and wanted to make a profit of $14? How could you use a profit line to show Otto that this would be impossible based on his current pricing? So basically $1 per car, $2 per truck again, and this time he wants to make 14, and we're going to show him that this is impossible for his pricing and his current situation, because we're just going to do the same thing that we did with the $8 line. We're just going to graph it. So there's an x-intercept of 14 and a y-intercept of 7. With my pen, an x-intercept of 14 and a y-intercept of 7, which is in between 6 and 8. I'm going to put my phone down to connect that. I've also labeled each of this. So this is the $8 profit and this is the $14 profit connected with 0, 7, and 14, 0. And you can see that he'll never be able to make $14 from this because it totally misses his shaded region. He doesn't have enough material at all to make $14. So as you can see, the line completely misses the shaded area. The line misses the shaded area. Shaded area completely. Yep, so he doesn't even have the material to make $14 profit. Last question is find Otto's highest possible profit if he gets $3 per car and $2 per truck. That's P equals $3 per car is 3x and $2 per truck is 2y. Find the profit expression, which we've already done, and find the best combinations of cars and trucks to maximize profit. So again, $14 he can't do, but can you do $3 and $2 per truck? What will be the most that he can get? You just plug in your corners again. So it looks like it'll be probably 6.2. I'm kind of just plugging them in my head. So let's see, 6.2. 3 times 6 plus 2 times 2, and that is equal to 18 plus 4 is $22. I believe that gets him the most. So if he makes 6 cars, 2 trucks, he'll get a profit of $22. So basically that's it for these word problems. Your assignment right now is, and you should have been copying this all down into your notes, but I do not need to see this. Like, you do not need to post the notes that you took. All I want to see is this problem right here. So flip to the last page of this attachment, the 4.2.2 part 1 review packet in the back of this packet. Review and preview. And you're just going to complete 4-83. So this is a different word problem. You're going to designate the variables so you can make the X your house cleaning hours and the Y your sales job hours. You're going to write the system of inequalities to show that you can't work any more than 12 hours at your 2 jobs and you need to earn at least $80 to pay your bills. So you're going to have 2 inequalities for this one. You're going to graph using the X and Y intercepts. So I should see your side work, or you can either do it in your head or show the side work, finding your X and Y intercepts to graph these lines very easily. Make sure you shade to show your solution region, scale and label your axes, and then you don't have to do anything with profit or anything like that. I just want you to identify one solution from your shaded area and test it like you've been doing normally. Again, if you have any questions, please post below or on Google Classroom. Good luck, and just post a PDF of this problem by midnight tonight. Thank you and goodbye.